Hello, everyone. Welcome to Calico Con. My name is Matin, Rasa. I'm a containers go-to-market specialist at AWS. Today, I'm going to talk to you about zero trust security best practices on Amazon EKS. So a little bit about myself. I've been at Amazon AWS about 2 years, and for the most part, I've been working on container services. And my role really involved supporting customers and helping them adopt our different container services. Obviously, today with the tailwinds behind Kubernetes, we see a lot of customers adopting EKS. And today I'm going to talk a little bit about how to implement best practices for workload security for applications and workloads running on Amazon EKS. So let's get started. I'm going to provide you an overview on what I'm seeing in the market and what we are seeing in the market broadly as AWS. A lot of you are practitioners who are working on modernizing your applications, or working on building the security posture, configuring your EKS or Kubernetes clusters. I want to provide, take it up a level and talk about what's broadly happening and, what sort of initiatives your organizations are driving and what sort of business benefits they're trying to achieve. Let's start by talking about why organizations build modern applications. Organizations really build modern applications to deliver speed and agility. To get to market faster, they want to respond quickly to changes in their markets. From past experiences, we know that customers who adjust and adapt quickly are more successful. However, what happens over time is that organizations spend a lot of time just keeping the lights on. With a cloud-based modernization, enterprise can spend more time writing code and less time managing the infrastructure that that code runs on. See, managing the infrastructure that that code runs on is typically undifferentiated heavy lifting, unless your differentiation lies at that layer. If you are the benefits that you're delivering to your customers are at that application level, then working on the infrastructure level is undifferentiated heavy lifting that you can offload to someone like Amazon or any other cloud service provider. The second reason is security and operational resilience. With a cloud-based security model, enterprises can build security into their infrastructure and not as something that's bolted on at the last step. For instance, certain deployment paradigms, such as AWS Fargate, provide container isolation as a feature and not something that's added on later. This is something that customers really look for in a container-based deployment model. Furthermore, the inherent nature of containers is to be able to react quickly to failures in certain services that are running. So that in itself gives an operational resilience to the workloads that are running on containerized environments. Finally, it comes down to cost. How often have you had to delay a project that didn't have the resources to get started? Cloud reduces this activation energy. It provides a lower activation barrier. Then eventually, as customers deploy in this containerized environment, they spend less money on infrastructure and focus more on their application layer. And these are not just concepts, right? These are not just abstract concepts that I'm talking about. We've seen several of our customers extract these benefits from their modernization efforts. For instance, Bridestory and Depop were able to release features 3 times faster by modernizing their application stack. Snap, T-Mobile, and National Australia Bank were able to reduce the time required to build new applications by up to 75%. Other customers, such as Vanguard, Ancestry, and Fender, cite the increased resiliency and high availability with the container-based deployment model. Costs are another major concern. And customers who leverage container and serverless-based architectures are able to reduce costs by more than 20%. Part of the reason for this level of organizational transformation is due to how compute technologies have evolved over the course of time. In recent years, compute has undergone a profound paradigm shift to containers and serverless, as companies seek deeper agility and efficiencies from their operations. As the graph indicates, we all began with physical machines where our ability to scale and change and innovate was somewhat limited by the amount of infrastructure, servers that were available in our data centers. And so gradually at first, with concepts such as CapEx for OpEx and leveraging elastic resources, things such as faster speed and agility, some of these benefits were starting to get realized by our customers. The third wave is containers, which gives you a high degree of mobility, and where agility started to become first and foremost through benefits like platform independence and faster deploys. Containers allows you to package applications and move them between different computing environments as well. So it gives you that mobility also, that portability that a lot of our customers are looking for. And then there is serverless, where you don't have to worry about any of that. And as we've learned already, this level of infrastructure abstraction has some very real benefits in terms of TCO, faster innovation, and generally implementing a sort of an organizational agility. Now, having talked about containers and serverless and this evolution, customers are still confused about our multiple offerings. And, some of our customers, like the approach that we have in terms of building modern applications. And they may say, hey, Matin, this is great. I've heard your modern application guidance in that webinar, but this doesn't work for us, right? We are an open source first organization and we're standardized on Kubernetes. Now that's fine. Like while we give advice and we highly recommend customers start and approach the container journey with a serverless first approach, either with ECS Fargate for container-based applications or with Lambda by re-architecting to an event-driven serverless architecture. We do understand that some customers have this open source first mindset and they want to standardize on Kubernetes. And for those customers, we have the best-in-class Kubernetes service in Amazon EKS. We highly recommend that you leverage EKS as you embark on a Kubernetes journey because it takes away the undifferentiated heavy lifting of managing an open source project like Kubernetes for your production workloads. Whereas for customers who want to optimize for speed of delivery, we highly recommend they start with the serverless first approach and then move on to something like ECS Fargate and Lambda and leverage those services as they embark on their modernization journey. In this talk, we're going to focus on Kubernetes and building applications on top of Kubernetes. Before we get started, let's take a step back, right? Kubernetes is this open source container orchestration framework. It's backed and governed by the Cloud Native Computing Foundation. It's seen broad adoption and growth over the last several years. And, it not just integrates the compute components, but also integrates key components of our networking, storage, and enables enterprises to run containerized applications at large scale. And as the adoption of Kubernetes has grown, so has the ecosystem around Kubernetes. Many times I've seen customers adopt Kubernetes just so they can leverage this rich ecosystem of open source and third-party ISV tooling around Kubernetes. However, we understand that running and managing Kubernetes at scale can be challenging. And there's a lot of work that needs to be done to configure your clusters and workloads for high availability, ensure you have the right security posture, which is what we're going to talk about later on in this presentation, and to make sure that the deployment can scale to meet your variable user demand. In addition, you have to plan for failure and disaster recovery as well. Enterprises who self-manage Kubernetes end up spending a lot of time on this undifferentiated heavy lifting. And this is why we built Amazon EKS. And we provide Amazon EKS as a service to our customers. Amazon EKS provides the flexibility of Kubernetes with the security and resiliency of being an AWS managed service. As customers move a larger portion of their workloads to Kubernetes, we're meeting the demands with Amazon EKS. And I'm going to talk about a few key attributes of Amazon EKS that our customers really appreciate about it. Firstly, we don't modify open source Kubernetes. EKS is fully upstream and conform with Kubernetes. So that ecosystem of tooling around Kubernetes that we talked about, we want to ensure that customers are able to leverage that tooling without any need to modify any sort of tool or any sort of custom configuration. This is why we strive to make sure that EKS is always conformant with open source Kubernetes. We are working to enable our customers to run mission critical workloads on Kubernetes. So we support upstream versions for a longer period of time. We typically support at a minimum 4 versions of Kubernetes. And this gives our customers sufficient time to roll out upgrades. We have to do a lot of work behind the scenes to manage and support these different versions. We backport fixes, upgrades, Kubernetes versions, and support versions that the community may not be actively supporting as well. And our goal is to provide a managed experience with Kubernetes where we do a lot of work to validate these different versions of Kubernetes and provide the best version with the right security posture for our customers. And lastly, we want to reduce the complexity of running Kubernetes in production. This is why we manage the control plane, and we are adding more managed layers to our managed worker nodes as well, as you will see from the EKS roadmap. Attestation of Amazon EKS is the hundreds of thousands of customers who are using Amazon EKS for their mission-critical workloads, whether it's travel companies like Skyscanner, social apps like Snapchat, or ISVs who are transforming their operations with EKS. Our customers are driving important innovations and addressing critical needs and bringing on mission-critical applications to Amazon EKS. I'm going to talk about a couple of examples of customers who've leveraged Amazon EKS for their mission critical workload. HSBC, it runs in a regulated environment. It's a financial institution, and they trust Amazon EKS for their mission critical workloads. Another great example is Arlo, who runs their machine learning workloads on Amazon EKS, and they leverage a lot of GPU instances. Arlo has been able to leverage Spot integration with Amazon EKS and reduce the cost of compute by more than 50%. So why do these customers choose Amazon EKS? These teams choose Kubernetes for its vibrant ecosystem, the consistent open source APIs, and the broad flexibility that Kubernetes provides. They rely on Amazon EKS to handle the undifferentiated heavy lifting of securely operating Kubernetes at scale. And customers who adopted EKS get the flexibility of a widely adopted open source container orchestration framework with the experience and reliability of a managed AWS service. Similar to HSBC, EKS customers are able to reduce the operational overhead, reduce cost, and de-risk their application deployments by leveraging the global scale and reliability of AWS infrastructure. More importantly, for customers migrating off of self-managed Kubernetes, the applications don't need to be re-architected. EKS is fully upstream Kubernetes, so if it works on Kubernetes, it will work on EKS. I'm going to talk a little bit about the high-level architecture of an EKS cluster. The control plane is fully managed by AWS, and the worker nodes can be either self-managed nodes, managed node groups, or fully serverless with Fargate. Users can access the cluster through the cluster ingress and load balancer. These are your end users who are accessing the application. You can layer on networking, policy management to define how services talk to each other, connect to external storage, meet your workload needs, choose from a variety of compute available with AWS, and define rules on which workload can leverage and what type of compute. Obviously, one of the key requirements for modern applications is observability, to monitor and observe the state and performance of your applications running on your cluster. Typically, DevOps or cluster admins manage the connectivity to the cluster, and that's what you see on the left over there. These are the users who go in, deploy applications, run kubectl, apply commands into your clusters, and they get admin access. And we'll talk a little bit about how to configure the permissions for these different users as well. All that comes under the bucket of security. And developers deploy their workloads with CI/CD pipelines into the cluster and monitor the performance of the applications within the cluster. Now let's talk about the runtime options for workloads within the cluster. 3 ways to provide capacity to your cluster: self-managed node group, where users are responsible for bringing their own AMI, bringing their own scaling groups, and they're responsible for the ongoing maintenance and patching of the worker nodes. With managed node groups, EKS handles the lifecycle of worker node rotation. We provide and make available an AMI. When the AMI is available, the customers have to initiate the automatic draining and rolling out of new AMIs. There is some automation in the upgrade process, but the customers are still responsible to initiate that. Managed node groups provides seamless integrations into AWS compute services such as Spot, integrations with Graviton, the ability to use GPU-based nodes, Inferentia, and more. It also provides integration to be able to leverage AWS Nitro-based instances that enable higher density and larger scale deployments. Finally, there's the serverless option with Fargate, where AWS manages the compute to provide capacity for your workloads. Containers run within an AWS managed VPC and connect back to your private VPCs. With AWS Fargate, you don't have to manage any compute. You focus on your applications, you configure your task or pod definition, and AWS manages the infrastructure on your behalf. With that overview on EKS, let's move on and dive a little deeper into what this talk is actually about, which is securing your applications on EKS. So security is everyone's job. In the context of modern applications, and as we move to more agile infrastructure, we need to think a little differently about security than we did before. In modern applications, security features have to be built into every component of the application. Each component is automatically tested and deployed with each release. In a modern applications paradigm, security can no longer be just the responsibility of the security team. Rather, security has to be deeply integrated into every stage of the development lifecycle. Everyone in your organization has to play a role. And this is where the concept of zero trust comes into play. Security has to be integrated within the tooling, into the release pipeline itself, into the software being released, what sort of permissions you set on the CI/CD pipeline, what services can you leverage, either AWS services or third-party ISV services, to maintain the right security posture What services can you leverage to audit that security posture? You need to think about container security slightly differently also, because all of the stuff that I talked about, is applicable to a VM-based deployment model as well. Like, what is different with containers? There are a few key differences in how containers applications are deployed, and we need to think a little differently about security in the context of containers. So let's talk about that before we dive deeper into how you can configure zero trust for your workloads. So container execution, as we all know, is very different from a traditional VM execution. A VM model, you have a separate system. Each application is running on its own system with its own CPU, networking stack, and storage. Whereas in the container model, it's one where all the processes are running on a shared Linux kernel, and the isolation is provided by Linux primitives such as namespaces and C groups. These basically prevent processes from consuming too much memory or CPU, but this is nowhere close to the hardened isolation that you get with VMs. Also, containers are a more dynamic environment. They can be started and stopped far more frequently than VMs. Even if you're looking to run long-running processes on containers, it could be a web service, which typically a lot of customers run. While the service may have maybe a long-running service, and it has a certain fixed number of containers, the individual containers themselves can be started and stopped at various times for many reasons, right? And this is the inherent resiliency that a containerized framework provides. But also, you have to remember, these are ephemeral workloads. So you need to think about these differently. And the notion of a network team setting up a firewall or on a brand new VM instance with static settings does not quite work with containers. We need security primitives and models that are suitable for this dynamic environment. It's obvious many of the existing security software that is built for traditional computing environments are not container aware. And at the same time, you are running in a shared environment and you're running multiple different tools. Many a times the DevOps teams do not have visibility to what that application is that's running within the container is actually doing. The developers have that visibility. And these container images can originate from different sources and could be built using different base images pulled from various sources. So there needs to be a way to be able to detect and prevent malicious software from being run within those containers and getting into your container environment. And all of these different challenges with a containerized environment need a different approach. So in the next few slides, I'm going to talk about 4 key high-level principles. Right? I'm not trying to solve or provide you finer granular details into how to do this, but these are certain guiding principles that you can work on and implement in your organization to further consider how you want to implement your security posture, and then dive deeper into each of these different areas and figure out how you want to do it eventually. Through the rest of the talk, I'm going to focus on these 4 key security principles to securing your modern applications. The first is you are running in a shared environment. So you need to understand the shared responsibility model, knowing what you as a consumer are responsible for and what your provider, your cloud service provider, or your ISV is responsible for. And this can change depending on which service you're leveraging. The second is based on the principle of least privilege access, or limiting the scope of permissions. Obviously, this is a shared environment. You want to consider what sort of permissions you give each user who's operating in this environment. And the third is defense in depth. You have multiple layers of your tech stack. You want to implement mitigating controls in these multiple layers. Either it could be within your tech stack, going top to down, or entry points within your cluster. Like you have different entry points into your infrastructure. It could be the DNS, it could be a firewall, it could be your ingress into your cluster. You want to make sure you have mitigating controls at each of these different layers. And finally, you are running multiple pieces of code within your cluster. You may be using different open source tools or third-party ISV tooling. You want to make sure that you can secure your software supply chain, that you are operating on a secure software supply chain. So starting with the first principle is the principle of shared responsibility. It's super important to understand what mode you're operating in. So within the context of self-managed node groups, you are responsible for everything on the left of the yellow line. AWS is responsible for the EKS control plane and managing and operating that. And you're responsible for everything that starts from the OS layer, kubelet, the AMI configuration, all the way to your customer data. You are responsible for that. This changes a little bit when you move to managed node groups, where AWS makes the AMI available when we have a new release. And it is then your responsibility to rotate your nodes and make sure that they have EKS optimized AMI running on them. This changes further when you're operating in a Fargate paradigm, where AWS handles the node AMI rotation as well as the workload scaling. It's important to understand what mode you're operating in and what you're responsible for. The next is the principle of least privilege. Now, least privilege involves granting only the necessary permissions to perform a task. A few key things to remember in this is authenticate all users into a cluster. When I say authenticate, make sure that each user is accessing the cluster based on their defined organizational role. Do not grant admin permissions to all users. Do not create one admin user and then share the password with a bunch of different users. All these are recipes for an attack. Also, another key best practice is separating out your production and dev clusters. So any attack or any incident in your dev clusters will not impact your production clusters. At any point of time, you have an environment that is up and running. You're reducing your blast radius there. Furthermore, consider limiting how many and which users have access to the production environment. With AWS, access is controlled with IAM policies and roles. And with EKS, you can attach an IAM role to a service account. So this role specifically gives applications permission to call other AWS APIs. Now, these APIs could allow a specific pod or a service to get an object from an S3 bucket or put data into an Amazon DynamoDB table. For each of these, we recommend that you use a unique role for each service and application, as this makes it easier to tightly control what work is going to be performed by that particular application. If you typically give out these blanket permissions to all of your services, it's very hard to control what each service can do. And the principle of least privilege forces you to think about these permission boundaries, like what specific tasks is the service going to be performing, and what permissions should it be given to perform these tasks. Now, I touched upon this in the previous bullet. As you're granting these privileges to these applications, if you're running in the dev environment as you're testing out these applications, it may seem easier to just give star permissions to all of these different services. However, we highly encourage you to scrutinize, in fact, avoid using star permissions. Grant users, not just users, but also applications and services, just the right amount of permissions based on least privilege that is necessary to perform the task. If a particular pod is compromised, what happens is if a particular pod is compromised, it may have access to other services that the cluster has access to. And furthermore, finally, audit periodically. Use AWS services such as Access Advisor and CloudTrail Insights. Kubernetes also provides logs. We provide you the Kubernetes audit through CloudWatch. Audit them periodically. Take a look at what actions been taken inside the cluster. Make sure that those actions match the security posture that you want to implement, or match the role that a particular user or an application has within the organization. So audit those periodically and make sure that those are truly representing the kind of security that you want to implement within your environment. Moving on to the third principle, it's about securing your software supply chain. Security is everyone's responsibility, as we talked about earlier. And obviously, we need to train our developers to think about writing secure code, ensuring that each component, whether it's open source or third-party software, is free from vulnerabilities. That you're picking the latest versions, or you're picking the versions that are known to have no vulnerabilities. And here's a few key things to remember when you're thinking about your software supply chain. Keep it simple, right? Try to break down your applications into kind of a single responsibility function instead of these highly complex ones with, they have a lot of branching logic. The application code is doing a lot more, like it's collecting data from S3, for instance, and then going and updating an Amazon DynamoDB table, then making some updates to another database. You want to limit this. In some cases, it may not be avoidable, but you want to limit this as much as possible. Again, go back to the principle of least privilege. What are the least set of privileges that I need to provide this application? If it has a complex logic, figuring that out might be hard as well. It may not be possible all times, but keeping it simple, simpler functions, single function code, that will greatly reduce the complexity. The second one is pretty obvious. Never hard code any secrets in your code, right? Or in your pipelines. We don't recommend embedding secrets within your Git repository as well. Instead, use purpose-built services for this, right? Amazon Secrets, AWS Secrets Manager. When needed, your code with the right permissions can retrieve these needed secrets during runtime or during initialization. They can execute code with those secrets. Consider implementing checks within your source control, right? In your source control, as code is checked into your repository, do a scan to see if there's any sort of secrets that are embedded, and catch these when the code is checked in before the code is deployed. Finally, leverage vulnerability scanning. Like a lot of times you're running open source software, you want to make sure that there are no vulnerabilities in the code that you're deploying in your cluster. So leverage code and vulnerability scanning. Do this as part of your build pipelines. Scan dependencies as well, and make sure you keep those dependencies up to date. There are some great partner solutions that provide these vulnerability scanning, as well as Amazon ECR, our container registry, supports vulnerability scanning. So leverage these capabilities to scan your container images. Lastly, the fourth principle is practicing defense in depth. And this means that security should be embedded into every aspect of your application by implementing multiple redundant measures across systems to address common attack vectors. AWS provides a variety of integrations and managed services to help you set up these measures across different services that you're leveraging. You can set up Kubernetes network policies, and these are network security policies that allow you to control access and communication between different applications. Network security policy specifies how pods communicate with each other and other network endpoints. They define egress and ingress rules. Right? You can, default deny access to a particular service, or only allow a service to be accessed by another. Let's say service B can only be accessed by service A. Typically, these network policies are implemented by the CNI plugin. The AWS CNI plugin today does not have a policy engine. Typically, EKS clusters need a policy engine such as Calico to support security policies. Network policies does not support controlling access to AWS resources outside of the cluster. And this is achieved through security groups for pods. Now, security groups for pods integrate with Amazon EC2 security groups with Kubernetes pods. Users can use security groups for pods to control which AWS services your apps have access to. Users can define rules that allow inbound and outbound network traffic to run from pods that you deploy into your Amazon EKS cluster. I know some customers use a service mesh to secure and encrypt pod-to-pod communications. We've also launched Amazon VPC Lattice, which is a managed service that secures communications between your services. All of these different tools allow you to secure your systems from external attack. Another function that they do is they reduce the blast radius of an attack, not just preventing an attack, but also by implementing these controls at multiple levels, you reduce the blast radius of an attack and quickly isolate and quarantine compromised pods. So finally, to summarize, security is everyone's responsibility, as we discussed. What I want to leave you with is understand the shared responsibility model. Know that you have to grant least privilege, implement security and defense in depth, and secure your software supply chain. If you want to learn more, you can do a hands-on workshop with Calico on EKS. I've provided the link there. And Calico Cloud is available on the AWS Marketplace. They've been a great partner for customers who are running workloads on Amazon EKS, and I highly recommend you check it out. With that, I thank you very much for listening to my talk, and please do reach out to the Tigera team or to your AWS reps for more information on Amazon EKS or on Calico Cloud or what Tigera has to offer. Thank you very much.
Cloud-native applications can't be secured with the traditional security tools. You need a more active and granular level of security. Calico Cloud is an active cloud-native application protection platform that detects, prevents, and mitigates breaches in cloud-native applications. Let's look at how to secure your cloud-native environment at build time with Calico's container security. At build time, we want to make sure that images that the development team provides are clean and without major vulnerabilities or misconfigurations. All image registries are auto-populated and continuously scanned by Calico's scanning engine. I can also manually add new registries. It's very easy for me to see the results of the last scan from the scan results page. Pass-fail is color-coded with specific scores. Details about each vulnerability that impacts each image are available on the right side. I can control which images can be displayed to my environment using admission control policies. I am only allowing images with pass or worn scan results. I've also enforced an upper limit for the age of a scan result. Now, if any application developer attempts to deploy an image that doesn't pass the security criteria, it will automatically be blocked. Once you have the admission policies in place, you may come across a situation where the application developer is telling you that a particular vulnerability does not impact their code and the way in which they are using the affected library. In this case, you need to create an exception. Calico Cloud offers a number of options to scope the exception to a specific image version, any version of this image, or any image. In addition to scanning and assessment of images, I must ensure the Kubernetes environment is also secure and does not have any misconfigurations. Calico helps you continuously assess your Kubernetes configuration using compliance reports that assess your configuration against CIS benchmarks. I scheduled my CIS benchmark report to run every 24 hours. The number of nodes passing or failing the CIS benchmark tests is color-coded. And here are the top failed tests. I can also download the full report to get more insight on each test and how to mitigate its risk. At this stage, I have scanned all my images, allowed the deployment of only those that pass the security requirements, and I have also assessed my deployment environment against CIS benchmarks. Try it yourself by signing up at www.calicocloud.io. Cloud-native applications can't be secured with the traditional security tools. You need a more active and granular level of security. Calico Cloud is an active cloud-native application protection platform that detects, prevents, and mitigates breaches in cloud-native applications. Let's look at how to secure your cloud-native environment at build time with Calico's container security. At build time, we want to make sure that images that the development team provides are clean and without major vulnerabilities or misconfigurations. All image registries are auto-populated and continuously scanned by Calico's scanning engine. I can also manually add new registries. It's very easy for me to see the results of the last scan from the scan results page. Pass-fail is color-coded with specific scores. Details about each vulnerability that impacts each image are available on the right side. I can control which images can be displayed to my environment using admission control policies. I am only allowing images with pass or worn scan results. I've also enforced an upper limit for the age of a scan result. Now, if any application developer attempts to deploy an image that doesn't pass the security criteria, it will automatically be blocked. Once you have the admission policies in place, you may come across a situation where the application developer is telling you that a particular vulnerability does not impact their code and the way in which they are using the affected library. In this case, you need to create an exception. Calico Cloud offers a number of options to scope the exception to a specific image version, any version of this image, or any image. In addition to scanning and assessment of images, I must ensure the Kubernetes environment is also secure and does not have any misconfigurations. Calico helps you continuously assess your Kubernetes configuration using compliance reports that assess your configuration against CIS benchmarks. I scheduled my CIS benchmark report to run every 24 hours. The number of nodes passing or failing the CIS benchmark tests is color-coded. And here are the top failed tests. I can also download the full report to get more insight on each test and how to mitigate its risk. At this stage, I have scanned all my images, allowed the deployment of only those that pass the security requirements, and I have also assessed my deployment environment against CIS benchmarks. Try it yourself by signing up at